Alright, so another very important idea in algebra, and not just in algebra, but in many real-world contexts, is the idea of slope. And another way of referring to slope, there's actually several different ways of referring to it, and I've listed some of them here. Another way of referring to slope is the rate at which something changes. If there's a constant rate of change, then you have what's called a linear slope. The slope of a line is always constant, it always goes up or down at the same rate. So a couple different ways of referring to slope. You can refer to it as slope or the rate of change or the rise over the run. That means the vertical rise over the horizontal run. This right here, this symbol, the little triangle with the y, triangle x, that means delta. Delta is a Greek letter or symbol which means change. So the change in y over the change in x. And this formula right here, that's exactly what that means. The change in y means take your second y coordinate and subtract it from your first y coordinate. So that means find the difference in the y's, and you divide that by the difference in the x's. That's exactly what the slope is. Slope is the change or the difference in the y's over the difference in the x's. So a really simple real-world example. Let's suppose that somebody is 5 feet tall, and 2 years later they are 6 feet tall, let's say. So my question is, what is the rate of change in their height? Well, you would say they went up vertically by 1 foot, and that was done over 2 years. So they're basically doing 1 over 2. They're doing a half a foot per year. That is their rate of change in their height. So that's what we mean by slope. So let's use that idea to find because that's our first goal is to understand what is a slope, and the second goal is to, as it says up at the top, how do you find a slope of lines? So we'll do a couple examples of that right now. Okay, so the first one, how will we find the slope on number 1 of that line? And we can use this formula right here, the change in y over the change in x. So let's find 2 points. So they're giving us 2 points here. That point, remember the point right in the middle is at 0, 0. This point looks like it's over 1 on the x-axis and it's down 3 on the y. So if we go to the right 1, that means x is 1. And if we go down 3, that means y is negative 3. And I'm going to call this my first x coordinate and my first y coordinate, because we have another one right up here, as you can see. This one, which I'll call my second x, that's what the x with the little 2 means, and y sub 2, our second y. That one looks like x is equal to 4 right there, and y is equal to 2 right there. So now we can use this formula, y2 minus y1 over x2 minus x1. So y2, you can see right here, y2 is equal to 2 minus, that's a negative 3. So 2 minus a negative is like 2 plus. 2 plus 3 is 5. And then x2 is going to be 4, so I'll put that there. x1 is 1. You have to make sure that you follow that order. So 4 minus 1 is 3. My slope is 5 over 3. Now you might have a question, did you have to do it that way? Could you have picked this number here? Could you have picked this number here to be your y2 and that to be your y1? And yes, you could. I'll show you right now. So suppose you had done negative 3 minus 2 instead, so you're swapping these. Okay, if you do that, because you pick this as your y2, you have to now pick this as your x2. You can't mix and match. You can't go back and forth. So it's going to be this number 1 minus that number 4. Negative 3 minus 2 is negative 5, and 1 minus 4 is negative 3. Negative 5 over negative 3, that's the exact same as positive 5 over positive 3. So you can see you get the same answer as long as you stay consistent. You pick from the same coordinate pair in each case. Okay, what's the slope right here? Well, you don't even really have to do the math for this one, but we'll do it anyway. Okay, this point, this first one right here is 1, negative 3, and this second point right here is 3, negative 3. So if we follow our formula, y2 minus y1 over x2 minus x1, y2, let's call it negative 3, minus another negative 3, that's like plus 3, and then this will be 3 minus 1. Okay, negative 3 plus 3 is equal to 0 over 2, and that just equals 0. And you can see from looking at that, that's a horizontal line. The slope of any horizontal line, it doesn't have a slope. Think of it like climbing a hill. Okay, in this first one, you can see we had a positive number. That's because this line is like climbing up a hill. Right here, it's like you're walking on a flat road. On number 2, this is just a horizontal line. You're not climbing at all, so it makes sense that the slope would be 0. Okay, in this case, number 3, we'll also use our slope formula again. And by the way, the letter that stands for slope is M. And I believe, from what I remember reading, I don't know if this is exactly true, but the word for climbing in both Spanish and French starts with an M. In Spanish, it's montar. That's the Spanish word for climb. And in French, I believe it's monter, to climb. So I think climbing refers to, if you're climbing a mountain, obviously you'd be climbing up a slope. I'm not certain that's where it comes from, but I do recall reading that. So take that with a grain of salt. But anyway, here's our 2 points right here. We have the points looks like -4, -3, and this one down here looks like -4, -4. So let's plug this in. So y2, let's call that y2 minus y1, -4 minus -3 is like +3, and that equals -1. And then we have x2 minus x1, -4 minus -4 is like +4. So here's a problem. We're dividing by 0, and you can't do that. If you try it on a calculator, you can try it right now, you'll get undefined. So a vertical line like this one has an undefined slope. Every horizontal line has a 0 slope. Every vertical line has an undefined slope. It's literally so steep that you can't even climb it. Imagine trying to climb a mountain that was just a straight vertical. You really can't do it. You need at least some kind of horizontal run in that case. Alright, number 4 is the same type of thing. The only difference is now they're not giving us a graph. So let's just call this x1 and this x2. Call this y1, this y2. See if you can pause it and try and find out what the slope would be. So this is our formula again. y2 is going to be 1 minus y1 is -17. 1 minus -17 is like 1 plus 17, which is 18. And then x2 is -1 minus x1 is 14. -1 minus 14, -15, and then we can reduce that. 3 goes into this number 6 times, and it goes into that number 5 times. So -6/5. So if you were to actually plot these points, you would see a negative slope. It would be going down like that. Alright, last one. I told you that slope is used a lot in real-world scenarios. A good example would be in finance. Business, anytime things are changing at a constant rate, you would use slope. We'll just use this temperature example right here. It says on a warm summer day, the temperature readings at an airport. A lot of airports are the places where they have the official temperature gauge for that city. Temperature readings at an airport are as follows. What's the rate of temperature change? So we would probably want to do degrees per hour. That would make more sense. If I asked you which would make more sense to you, hours per degree or degrees changing per hour, that would be definitely more a common way of saying it, degrees per hour. So it looks like over here, remember, slope stands for the change in y, or the change in the dependent variable over the change in x. Okay, and the temperature here depends on the time. The later in the day it is, the hotter usually it's going to be, especially in the summer, until you get to a certain point at night. So here it looks like we're going up 1 each time, so the change in x is 1. The change in y looks like each time we're increasing the temperature by 4. And you can use the slope formula for this. You can just pick any x value and any y value here. So let's do 89 minus 85. 89 minus 85, and that equals 4 over 9 minus 8. We didn't have to choose those points. You could choose any one that you want. 9 minus 8 is that. So our slope is just 4 over 1 or 4, and that means 4 degrees per hour is the rate of increase, or the slope, the rate of change right there.